Good day. I welcome you all at the lecture on population forecasting methods of the subject Environmental Engineering. The subject code is CE701 and the related module number is 1. Myself, Sandeepan Saha, Assistant Professor for the Department of Civil Engineering of Greater Kolkata College of Engineering and Management under JIS Group. In our previous lecture, we have gone through various kind of water demands and requirements, which are very important parameters for designing a water supply scheme. In our current lecture, we will go through various kinds of population forecasting methods, which are also very important aspects for the serviceability of a water supply project. So let us first look into the topics that we are going to cover in our current lecture, which are as follows. That is, we will be covering design period, population forecasting methods, and numerical examples. Design periods and population forecasting. These two entities are very important for designing a water supply scheme. The design period should be worked out with due provision for the estimated requirements of the future. The future period for which a provision is made in the water supply scheme is known as the design period. Design period is estimated based on the following. Number 1, useful life of the component, considering obsolescence, wear, tear, etc. Number 2 is expandability aspect. Number 3, anticipated rate of growth of population, including industrial, commercial developments and migration immigration. Number 4 is available resources, and number 5 is performance of the system during initial period. Population projection and water demand assessment has been an integral part of various feasibility studies, detailed project reports, and master plans being prepared for water supply projects in the urban sector. It is necessary to have inputs of population forecasts for the service area of a project before water demand assessment can be made. There are a number of alternate methods to forecast future population for urban or rural service areas. It is not always possible to make accurate population forecasting except for immediate future. However, it is advisable to use these methods to have alternate population forecasts and then select one of them for use in water demand assessment. It must be remembered that the population forecasts for distant future will lead to a general idea of the overall picture of water supply or sewerage system needed in the long run. The system to be executed will be generally for the initial phase for immediate future for which the population forecasts can be reasonably sound. The overall system identified based on the approximate forecasts of population for distant future allows the designer to ensure that the initial phase system which is going to be executed fits the overall system in the long run. There are various methods adopted for estimating future populations as given below. The particular method to be adopted for a particular case or for a particular city depends largely on the factors discussed in the methods, and the selection is left to the discretion and intelligence of the designer. The population forecasting methods are as follows: arithmetic increase methods, geometric increase method, incremental increase method, decreasing rate of growth method, simple graphical method, comparative graphical method, ratio method, logistic curve method. As we have already understood that the population forecasting is very important for the serviceability and sustainability of a water supply scheme, let us do some numerical problems based on the population forecasting methods as mentioned here. In our current lecture, we will try to concentrate to do the numerical problems based on the arithmetic increase method, geometric increase method, and incremental increase method. First, let us do a numerical problem as per the arithmetic increase method. Let us do a numerical problem on population forecasting as per arithmetic increase method. Here is the problem. The population of 5 decades from 1930 to 1970 are as follows. From 1930 to 1970, the population are given here. So now we have to find out the population at the year 2000. In order to solve the numerical, first we need to calculate the increase in population over the decades. From 1930 to 1940, the increase in population was 28,000 minus 25,000. So it is 3,000. By applying the same method, we can calculate the increase in population from 1940 to 1950. So the increase in population is 6,000, 34,000 minus 28,000. From 1950 to 1960, the increase in population was 8,000. And from 1960 to 1970, the increase in population was 5,000. So the column is increase in population. So the total increase is equals to 22,000 over the 4 number of decades. That is the number of decades we can find from 1930 to 1940. There is 1 decade. In between 1940 and 1950, there is 1 decade, and in between 1950 and 1960, there is another 1 decade, and in between 1960 and 1970, this is another 1 decade. So now we have to calculate the average increase in population. So we'll get it by dividing the total increase, that is 22,000, divided by the 4 number of decades. So we get the average increase in population, that is 5,500. Now to calculate the population or to forecast the population in 2000, we need to perform this particular calculation, that is population in 1970 plus number of intervals, rather than I should say it as number of decades between 1970 and 2000 multiplied by X bar, that is the average increase in population. So putting the values of population in 1970, which was as per the given problem, that is 47,000 plus the number of decades between 1970 and 2000 is 3 multiplied by X bar, that is 5,000 and 500. So calculating all together, we get the value of 63,500. So as per the arithmetic increase method, the population in 2000 would be 63,500. Now let us do the same problem by applying the geometric increase method. Now we will try to solve the same problem as per the geometric increase method. And in order to do so, first we need to calculate the increase in population as we have done in the arithmetic increase method. So as we know that in between the 1930 and 1940, the increase in population was 3,000. From 1940 to 1950, increase was 6,000. From 1950 to 1960, the population increase is 8,000, and in between 1960 and 1970, the population increase was 5,000. So now we have to calculate the percent increase in population, or we call it growth rate. It can be denoted by R. So R1 is calculated by 3,000, that is the population increase in between 1930 and 1940, divided by the population during 1930, that is 25,000, and making it as a percentage, we multiply this by 100%. So we get 12%. So in between 1930 and 1940, the growth rate was 12%. The same process we apply, we get R2, that is the growth rate between 1940 and 1950. And how do we get it? We get this by dividing 6,000 by 28,000 and making it as percentage. We get the growth rate in between 1940 and 1950 as 21.4%. Same we get R3. So we calculate this by dividing 8,000 by the population in 1950, that is 34,000 into 100%. We get the growth rate as 23.5% in between 1950 and 1960, and in between 1960 and 1970, the growth rate we get, that is 11.9%. And how do we get it? By dividing 5,000 by 42,000, that is the population of 1960. We get the growth rate in between 1960 and 1970. So now we have to calculate the geometric mean, that is, how do we have to calculate the geometric mean of of the growth rates. And how do we do this? We do this applying the this formula. We have four number of growth rates because there are 4 decades in between 1930 and 1970. So putting the values of R1, R2, R3, R4, we get the geometric mean of the growth rates as 16.37%. So the population in 2000 as per geometric increase method, we have to use this formula, that is population of 1970 multiplied by 1 plus R by 100 whole to the power n. Here R is the value of the geometric mean that we have calculated already, and n stands for number of decades between 1970 and 2000. So applying those values, we get 47,000. That is the population of 1970. 1 plus 16.37 by 100 whole to the power 3, as the number of decades between 1970 and 2000 is 3. So calculating all the values, we get the population of 2000 as 74,000 and 66. So this is the population of 2000 calculated as per the geometric method. Now let us solve the same numerical problem using the incremental increase method. Now we will be solving the same problem by using incremental increase method. In order to do so, first we need to calculate the increase in population over the decades, that is in between 1930 and 40. the increase in population was 3000, and in between 1940 and 1950 the increase was 6000, and in between 1950 and 1960 the population increase was 8000, and the population increase between 1960 and 1970 was 5000. So further we move to the calculation. Now we will have to calculate the incremental increase. In population. So how do we calculate? We calculate this in case of between 3000 and 6000, there is the incremental increase is in positive side. The incremental increase is in the positive side. That is 3000. We consider this as positive. Again, the next incremental increase calculation is between 6000 and 8000. So the incremental increase is 8000 minus 6000 equals to 2000. Again, the incremental increase is in the positive side. But in case of the 8000 and 5000, the incremental increase is 5000 minus 8000. So it is in the, so the incremental increase in population is in the negative side. So the net incremental increase is equals to 3000 plus 2000 minus 3000, as we can get from here. So we have 2000. So the average incremental increase equals to 2000 by 3 decades. That is, the incremental increase can found in 3 decades. So we have 667, and we denote this as y bar. And here we have the, and from here we can get the average increase in population that is x bar, which is the total increase in the population was 22,000, divided by 4 number of decades, as we can find in between these years, that is from 1930, in between 1930 and 1970, we have 4 number of decades. So dividing 22,000 by 4 number of decades, we get x bar equals to, that is the average increase in population was 5,500. Now, in order to calculate the population in 2000 as per the incremental increase method, we need to apply this following formula, that is population of 1970 plus nx bar plus n multiplied by n plus 1 by 2 into y bar. Here x bar, sorry, n equals to number of decades between 1970 and 2000. So we have the population in 1970, that is 47,000 plus n equals to 3 as the number of population, sorry, the number of decades between 1970 and 2000 is 3 multiplied by x bar, that is 5,000. We have got this from here, plus n equals to 3, that is number of decades between 1970 and 2000, multiplied by 3 plus 1 divided by 2, and y bar, that is 667. We got this from here. So calculating all together, we get the population in 2000 as per the incremental increase method is 67,502. So the population of 2000 as per the incremental increase method is 67,502. In this lecture, we have studied details of water demand along with the various population forecasting methods, which are very important for designing a water supply scheme. Thank you.